Good morning. Network address translation. Network address translation. Network address translation. We call this NAT. 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 NATing. So why should we do network address translation? With the development of the internet and the increase of network applications, limited public IPv4 addresses have become a bottleneck for network development. Limited. How many addresses does IPv4 give us? 2 raised to power 32, right? Around 4.3 billion addresses, right? Yeah. So when the creators of IPv4 created this address space, it was just too huge at that point in the 90s. They couldn't imagine that 4 billion addresses could be depleted. But just a few years ago, most regions depleted their pool of IPv4, public IPv4 addresses. Now, in order to slow the depletion rate of IPv4 addresses, what was introduced? NATing. NAT. NAT enables hosts on an internal network to access an external network. It not only helps alleviate IPv4 address shortage, but also improves the security. Look here. NATing also does what? Improves the internal network, as NAT prevents devices on the external network from directly communicating with hosts on the internal network that use what? That use what? That use private addresses. So in the internal network, we use private IP addresses. On the external network, we use public IP addresses. So people that are outside cannot be able to communicate with people that are inside if we've not allowed them to do so, because they have to go through our router. And if an association is not there, their packet is going to be discarded. So NATing also is viewed as one of the network security measures that you can take in order to secure your internal private network from the external public network. So this course describes the motivation behind NAT and implementations and application scenarios of different NAT types. So I hope we understand it. It's a very interesting topic. By the end of this chapter, you should be able to, Dennis?
On the completion of this course, you'll be able to understand the motivation behind NAT, master NAT classification and implementation, master NAT selection in different scenarios.
Wonderful, wonderful. Okay, so let's have the overview of NAT. The problem is this: number of internet users increase. By talking about internet users, we're also talking about the number of devices, while the number of public IPv4 addresses so to overcome IPv4 address shortage, it is necessary to use what we call transition technologies. So one of the transition technologies is NATing. So when we were learning about IP addresses, we said that in every class from class A, B, and C, in every class, we have a range of private IP addresses. So those IP addresses, we can use them within our internal network. And because they're private, different organizations can reuse the same IP addresses within their internal private network. Is that clear? Okay, so let's see how this works. So IPv4 addresses from class A reserve the 10.0.0.0, the whole of it as private IP addresses. Expect a question in the exam giving you an IP address and asking you whether it's private or public, for example. Class B, 172.16 to 172.31, the whole of that range. Class C, the 192.168, the whole of that range, 192.168. So in the exam, they'll tell you that these, they'll tell you that this is a private IP address. Then you'll select between true or false. Is this a private IP address? Does it lie within any of this range? No. Okay. So public IP addresses are managed and allocated by dedicated organizations and can be used for direct communication on the internet. On the internet. IANA, the Internet Assigned Number Authority. IANA. If I'm not wrong, Internet Assigned and Numbering, is it Numbering Authority? Something like that, Numbering Authority, IANA, is the one that is used to manage public IP addresses. Normally, the world has been divided into different regions so that IP addresses can be allocated in terms of blocks, so that we have continual allocation of blocks. So for example, in Africa, we have what we call the Afrinic that is responsible for our IPv4 block. Afrinic is the only block that is remaining with a few public IPv4 addresses. All the other have depleted their pool of public IPv4 addresses. So that is Afrinic. Afrinic, on the other hand, will assign countries with certain blocks of IP addresses. For example, they can assign KENIC for Kenya. Then KENIC will assign blocks to ISPs. Then ISPs will assign blocks to their customers. So for example, our ISP here is KENIC, the Kenya Education Network. KENIC. Sorry, KENET. So KENET can assign like 100 public IP addresses to MMU. It will be a block. By a block, we mean it's going to be following each other. So for example, 41.82. This is just an example. So for example, .1, 1 all the way, for example, to 41.82.1.100 or 101, whatever. So are you getting the point? And that's how websites, for example, are able to determine your location, because IP addresses are they are located geographically. Yeah? Okay. Private addresses can be used. Please note, we've said here that public are used for direct communication on the internet. On the other hand, private IP addresses cannot be used on the internet. They cannot be routed on the internet. What that means, you cannot have a source address between these values. You cannot have a source address and you're being routed on the internet. Are you getting the point? Are you together? So private IP addresses can be used by organizations or individuals randomly on their internal networks, meaning MMU can decide to use the 192.168 range. KU also uses that, so they can be used on different internal private networks. But they cannot be used for direct communication on the internet. So that is very important. That is very important. So you can see here we have a coffee shop that is using this 192.168.1.0/16, and it's being reused, the same thing, by the small scale factory pack and so on and so forth. Okay. So NAT implementation. So what NAT does is to map. NAT maps public to private IP addresses. So it translates IP addresses in the IP data packets. Now, NATing is widely used in live networks, and normally it is deployed on the network egress device, such as the router or the firewall So this is a typical application scenario. When Safaricom deploys fiber into your house, they give you the wireless access router. So that router will have a range of private IP addresses that they can assign to you when you connect to the internet. If you go to your phone networks and then you look at your IP address, it must be within the private range. Are you getting the point? It will be among the private range. But again, Safaricom has also assigned that device a public IP address. So when you're going out to the internet, then we translate, we change your source IP address from a private IP address to a public IP address. So that is exactly what is happening here. Look here. This is you with your phone. You have a private IP address, 192.168.1.10. So you want to access this server on the internet that has a public address, 200.1.2.3. So when you send the packet on step number 1 here, your source IP address is going to be 192.168.1.0. Are we together? Your destination IP address, the IP address of the web server. Now, when you get to the egress device that is performing NATing, your IP, source IP address, is going to be converted into a public IP address. As you can see, we've now changed the source IP address to the IP address of this interface here, which is 122.1.2.1. So after that, the destination, does the destination IP address change on the internet? Doesn't change, right? We still want to find this guy. So this packet will go up to this guy. Then this guy will reply on step number 3 here. What is the destination? What is the source IP address? The IP address of the server. What is the destination IP address? The IP address of our egress device. Are you getting the point? So this packet is going to come up to our egress device. Now, our egress device will maintain a mapping table between the public and private addresses. We're going to see how in a short while. But when it receives that with the source IP address of that, it's going to change with the destination, IP address of 122.1.2.1. It's going to change it on step number 4 here to 192.168.1 before sending it out to the internal network. So are you seeing that is what we call NATing? That translation between private and public and private when it's coming back. Are we together? Yeah. Now, you remember we said that people on the public network cannot be able to reach our private network, right? What that means is this web server cannot send a packet directly to this guy. Are you getting the point? They can't do that. I mean, they can't say that they generate a packet and then destination IP address 192.168.1.10. Are you getting the point? That cannot happen because number one, private IP addresses cannot be routed on the internet. Number two, we don't have that mapping here really. So that's how people on the public network cannot be able to reach our private internal network, which are using private IP addresses. So I hope that is clear. Eh? Okay, so NAT effectively conserves public IPv4 addresses because now internal devices won't need an IP address. Now we have 4 types of NATing. 4 types. We have static NAT, we have dynamic NAT, we have network address port translation. Actually, there are 5. And we have easy IP. So we have static NAT, we have dynamic NAT. Then we have network address port translation. Easy IP is almost like NAPT, but differs just a little bit. Then we have the NAT server. So in the coming slides, we want to understand the difference between these NATing types. And the other thing we need to understand is the application scenario for each one of them, the application scenario. Okay. So static NAT is normally referred to as a one-to-one NATing. One-to-one because it maps one private address to one public address, translates one public to one private. So really, with this kind of mapping, it does not conserve. It does not conserve really public IP addresses. So how so? This is what happens. you come in, your source address is 192.168.1.1. When you get to your egress device has a list of public IP addresses and the status. The status is whether they are available or unavailable. So you come in, then we find that, hey, we have a public address 122.1.2.1 that is available. So we update in a table that for 192.168.1.1, it's going out as 122.1.2.1. So now the source address is changed to 122.1.2.1 and sent over to the internet. Are you getting the point? Are you getting the point? Yeah. This guy that comes from here, 192, is going to be given a different public IP address. This one that is coming from .3 is going to be assigned a different public address. So this one is one-to-one mapping between public and private IP addresses, and therefore it does not really conserve IP addresses. That's what we call static NAT. Okay, so this is just an example, an illustration of how it works, which is something that I've already mentioned. But let's just look at the entire procedure, for example, for just this machine. So step number one, it creates a packet. The source address of the packet, its own IP address. It wants to access this server, the web server. So destination IP is the IP address of the server. Now, when this packet gets to the egress device, the egress device is going to convert the source IP address to a public IP address before sending it out to the internet. And finally, it's going to get to this guy. Then this guy is going to reply. In replying, that's what we have here in step number 3. The destination IP address is what was the source address when it received that packet. So it's going to reply to 122.1.2.1. When that particular packet gets to the egress device again, it's going to be, the destination IP address is going to be translated from the public one to the private one, which is 122.168.1.1. And that packet is going to be sent into the internal network. And finally, it's going to get to this guy. Okay. Okay. So in this second example, we can also just look at it. You can also look at this second example here. So we are having this external host wants to access our internal host 192.168.1.3. So the destination IP address is going to be the public IP address 122.1.2.3. Where are we getting this? In the previous slide, we mapped 192.168 here. Here we mapped this. So this one already is in our table. It is in our table here. That if anyone comes in with this, we translate it to this. Are you getting the point? Yeah, so the assumption is that that table is already there. So that is how then an external host will be able to access the internal. So that is what is happening here. So this guy wants to talk to this guy. The destination IP address will be this one. It gets to the NATing device. The NATing device changes from the public IP address to the private IP address 192.168.1.3, like that. Then if this guy wants to reply to this guy, then the destination is going to be the public address. Source, its own private IP address. When it gets to the egress device changes the source to a public IP address using that table that we've just seen. And the destination, of course, remains the same, which is the IP address of the external host. So that is how communication is facilitated both ways. Anyone with a question about this? Okay, so let's see how we configure static NAT. We can configure NATing either on an interface or globally, or on the global. So there are two ways of configuring NATing, either on the global or system view or on the interface view. Are we together? Yeah, please remember that. So by interface view, it means you go into a particular interface, for example, the G000, then you use the command NAT static global, then you give a global IP address. So use the keyword global, then a public IP address. A global address, it means a public address. Then inside, the keyword inside, then a private IP address. Are we together? So for example, in the previous, allow me not to use the full name here, 000. So for example, you'll do NAT static global, then 10.1.2.1. Then inside, so you want this to be translated to 192.168.1.1. So that's how you configure that. Otherwise, you can configure on the user view, on the system view, by using the same command, NAT static global, then global IP address inside that. But once you've done that, you need to configure on the particular interface that will implement NATing. You'll need to, so you have to go to on an interface, then use the command NAT static enable. Okay. Okay. Now, one main difference between configuring NAT on the system view and on the interface view, when you configure on the interface view, only devices that are connected to that interface, only, every interface of a router forms a network, right? So only devices within that network will be able to use that NATing. Are you getting the point? But when you configure NATing on the global, on the system view, then any other device connected via any other interface that has been enabled to use that NATing will be able to benefit from it. Are you getting the difference? Okay. So this is an example of configuring NATing, static NAT. Okay, so we are doing it on interface view. We go to the interface. We want to configure it on this on this interface here. So we give it a public IP address, and then we configure now the specific. So on the inside, we want, on the global, we want that. On the inside, we want that. On the global, we want that. On the inside, we want that. So for this particular architecture, that's how we configure the one-to-one mapping between public and private IP addresses. So that is what we call static NATing. So let's have an overview of dynamic NAT. Now, unlike static NAT, which does one-to-one mapping, this one does, I can call it many to many or something, many to many. You see, the problem with static NAT that implements one-to-one mapping is that when some internal hosts are offline for a long time or do not send data, the public address is still occupied by the host. So it wastes these public IP addresses. So in order to cater for that, they developed dynamic NATing. The assumption that dynamic NATing makes is that not all internal devices will want to access the internet at the same time. So the assumption is that internal hosts can be more than the available public IP addresses. Are you getting the point? So you're having 1,000 internal hosts, but you're just having 100 public addresses, because you assume that you can't have more than 100 internal hosts wanting to access the internet at the same time. So what happens is this, or is it in the next slide, by the way? I don't want to explain it, and maybe let's have a look. But just know that on the egress device, it has a NAT address pool that has a list of public IP addresses and their status. Is it in use or not? So we have fewer public addresses compared to the number of internal hosts that we have. That is how dynamic NATing works. And therefore, it is able at least to use these particular devices, these particular resources more efficiently. Okay, so let's see how it works here. Okay, so on step number 1 here, this guy, 192.168.111 wants to communicate to the web server. So it's going to send a packet. Source address, its own IP address. Destination address, the IP address of the web server. The source IP address is a private IP address. So when that packet gets to the egress device, the egress device is going to look at its NAT address pool. So it's going to look at the first one. Oh no, this one is in use, so I'm not going to issue it out. Then look at the second one. The second one is not in use. Oh, so then let me select this one. Now, in selecting that one, it updates its NAT mapping table. So step 2 generates a temporary NAT mapping table. So I've given 192.168.1.1 to 122.1.2.2. Then it will change. It will send that packet to the internet after changing the source IP address to that public IP address. Destination IP address remains the same. So that is what happens. Okay. On the way back, what happens? On the way back, the destination IP address is the public IP address 122.1.2.2. So when the egress device receives it, it searches this IP address on its NAT mapping table. Okay, so when it gets it, it's a match. Then translates the destination IP address from 122.1.2.2 to 192.168.1.1 and sends that packet to the internal network. And finally, it's going to arrive to that particular person. So that is how that is achieved. Anyone with a question? Question. Okay, so let's have a look at how to configure dynamic NAT. So with dynamic NAT, we configure it on the system view using the command NAT address group. Then we give it an index. The index specifies the address pool ID. Then we give it the start address and the end address. Start address and end address really are the public IP addresses of that particular pool. Are we together? The public IP addresses of the pool. For example, 200.0.1.1 to 200.0.1.100. So the pool. Now, after that, with dynamic NATing, you have to configure an SEL to match the private IP addresses. So we learned how to configure SEL. So SEL 2000, for example, you want to use a basic SEL, then rule permit source, the source private IP address and the source wildcard. So for example, 192.168.1.1, 0.0.0.255. So after you've done that, you now need to go to the interface, view, for example, gigabit Ethernet 0/0/0, and use the command NAT outbound 2000 address group. Then you use the index, the group index that you created here, the number. Then after that, you use the keyword no part, no hyphen part. No part means no port address translation. No port address translation. So we're going to look at what port address translation is just now. But for now, just understand that we must use that command no part in order to specify that we are not going to use port address translation. Okay, so an example of configuring dynamic NAT. Okay, so NAT address group. Then we have 122.1.2.1 all the way to .3. Then we create an SEL 2000 rule 5 permit anyone from this network. Anyone from this network. All these people. Then quit. Then we go to the interface and use the command NAT outbound. NAT outbound. Then the group number, the address group number, the SEL group number 2000. Address group 1. Then no part. So that's how we do that. Okay, now let's look at network address port translation and easy IP. Now, with network address port translation, unlike the previous ones that we've looked at, that were simply using the IP header information to map public and private IP addresses, this one goes on to also use the transport layer information. And the transport layer information really are the port numbers, the TCP and UDP port numbers. This therefore improves public address utilization to a greater extent compared to even dynamic NAT. So it's called network address port translation. Okay, so with this one, one public IP address can be mapped to multiple internal private addresses because we are also including port numbers. So how is that so? This guy comes with the source address of that, comes here. When it gets here, we give him this public IP address. But other than that, we also look at their port number. They have come in with 10,321. So you can see we have the IP address, but also the port number. So we map them to that IP address and the port number 1025. Then we send that packet out. We're going to see that. Otherwise, if this guy also comes in, .2, they have come in with a certain port number, so we record it. So this is the NAT mapping table. Then we send them out with the same IP address, 122.1.2.2, but a different port number, 10.26. So by using the port number to also map and differentiate packets, we are able to map several internal private IP addresses to a single public IP address. So I hope you understand that. Let's look at how that happens. Okay. So you can see this guy wants to talk to the web server. So source IP and the source port number on the TCP header, 10.32.1. So it gets to the egress device. The egress device looks at the NAT address pool and finds that it can be able to select this IP address. Now, when it selects that IP address, it is going to map it to the IP address of that particular packet and also initiate a port number. So 122.1.2.2, then full colon, then a port number, for example, 1025, like that. Then after that, it's going to send it out with that IP address and port number as the source address. So that's what happens. Okay. So when coming back, the destination is that IP address and the port number that was on the source of the received packet. When the egress device receives it, it checks its NAT mapping table and finds out that whoever has 192.1.2.2, 1025, then we have to translate it to this. And therefore, it changes the destination and the port to that. And that is how that packet is able to reach back to this person. Okay. So the only difference between configuring network address port translation and dynamic NAT is on this last formula here. We just don't include no parts. So we don't include no parts. Otherwise, all the other formula are the same. So everything else is the same as dynamic NAT. It's only that here we want to use port address translation. So we don't include the keyword no hyphen part. Okay, so the other important one is called Easy IP. Easy IP. Now, the main difference between Easy IP and network address port translation is that in network address port translation, you might have more than one public. Actually, you'll have more than one public IP addresses in your pool, as you can see here. You have a number of public IP addresses on your pool. For example, here we have 122. Here we just have one or something. Okay. Let me go back. Okay, good. So in network address port translation, you have a number of public IP addresses in your pool. On the other hand, with Easy IP, you only have a single IP address, public IP address in your pool. Otherwise, the working mechanism is the same. The working mechanism is the same. So with Easy IP, it means that everyone has to be, everyone in your internal network is going to be mapped to the same public IP address. The only difference, the port numbers. Are you getting the difference between NAPT and Easy IP? Now, you should not forget Easy IP because really, this is how your router, your wireless access router in your home, if you have fiber in your home, this is how your router is assigned an IP. Normally, Safaricom will connect to your router using what we call PPOE, point to point over Ethernet, and assign you a single public address. Are you getting the point? A single public address. Then everyone accessing the internet using that router is going to be mapped to the same public IP address. But now the only difference is going to be the port numbers. Yes, please. So she asked, is there a maximum number of port numbers? The answer is no, because you can't be able to exhaust the TCP port numbers. I'm forgetting the range, but we have different types of TCP port numbers. We have what we call well-known port numbers that are used by protocols from number 1 to 1024. They're called well-known port numbers. So for example, FTP uses port 20 and port 21, TCP port 20 and port 21. Are you getting the point? So all the way from 1 to 1024, they are used for protocols, the open protocols. Then from 1025, I don't know to what value, I can't remember. They are called random port numbers, and they can be generated randomly by your machines and used. So that's why all these port numbers you're seeing here, they're greater than 1024. Then from that, we have another set of port numbers. I think they're called private port numbers. I can't remember very well. But these port numbers are used by organizations or vendors like Huawei when they come up with their own protocols. So they can purchase those numbers and use them. So they're called private port numbers. So the random port numbers, they're quite many. They're quite many. Let's say they're 40,000. So I don't think you can be able to exhaust that at any point within a single network. Okay. So configuration of so listen, look here, look here, look here. This is your ISP. This is Safaricom. This is your router at your home. So Safaricom is going to give you a public IP address for this interface so that you can be able to access it. So that public IP address is what is going to be used by your phone, your smart TV, your smart fridge, your CCTV, etc., etc. So here we want to configure Easy IP on R1 to allow all hosts with the private IP addresses on the internal network to access the public network via 122.1.2.1. So we have to create an SCL. Rule 5, permit source. We enter the private address and the wildcard. Then we go to the interface. Then we simply use the command NAT outbound 2000. We're simply going to map all these IP addresses from this network to the public IP address of this interface. So that is what we call easy IP. I think the name came from the fact that it's also very easy to understand and easy to configure. Okay. The last one is called NAT Server. NAT Server. So what is NAT Server? So NAT Server maps an internal server. So for your servers, for example, your web server, you want your web server to be able to be accessed from the internet so that people that are outside your network can access your website or email through the web. So NAT server maps an internal server to a public network through a one-to-one mapping between a public address and port number. Look at this. So it's not the same. It can almost look the same as static NAT, but it's not the same. Because yes, it's one-to-one mapping, but we are mapping both the public address and the port number, and the private address and the port number. So really, that is how NAT server works. So what do we mean? What do we mean? For web servers, we know that for HTTP is used by web servers to transmit web pages over the internet. So HTTP uses the TCP well-known port 80. So when you want to access anything, you have to come in with port 80. So in your egress device, you are going to have the mapping, the one-to-one mapping between a public address and the well-known port, private address and the well-known port. It's one-to-one. So this public address cannot be used really with any other device. That mapping of that and that port cannot be used with any other device. Okay. So let's look how that happens. So we have a guy who wants to access our website. So they enter www.mmu.com .ac.ke. So within our network, we have a server where we've hosted our website. It's called a web server. So this guy will send a request. The destination IP address. So mmu.ac.ke will be translated to a public IP address using a technology we call DNS. We're going to discuss that later. So destination 122.1.2.1. The port number 80. So when our egress device receives that particular packet, it's going to look at its NAT mapping table and see that if you've come in with that, we are going to translate you to this 192.168.10, then port 80. Then it's gonna send it to the internal network, and finally it's gonna land to this person. So again, web servers will use the TCP port to listen for requests. Okay, so in going back again, the source address, the source port number, it gets to the egress that is mapped to that and sent to the destination. Are we together? Are we together? Yeah, so if you want your servers to be accessible from the internet, you have to configure the NAT server. The NAT server. Please remember that. These are things, by the way, you're doing. Nothing you must do as a junior network engineer. You must do, because all internal networks use private IP addresses. Okay, so how do we configure? How do we configure NAT server? You go into an interface, you give it an IP address. So we've just given this interface here an IP address. Then the command is NAT server protocol. So protocol that we're using is TCP global, then the public IP address, then the service. So this service is www. By default, www uses port 80. So it simply means 122.1.2.1 80 or 8080. Then inside 192.168.1.10 port 8080. So that is how we configure. That is how we configure NAT server. Ladies and gentlemen, that is the end of this topic. Please find some time to go through these questions. If anyone has a question, please ask. Okay. Asanteni. Asanteni sana.